Okay. So. Hello? Oh no, this changed. Right. And this changed to what? Hold on a sec. What did this change to? Okay. Um, this, but 28. And this. Hey, yeah, I can do that. I started out realizing this is my local IP got updated, so I just have to fix these URLs. But yes, I will update the size. Just need to update this, and then we can get going. Okay, let's switch back over and yes, please. Oh God, what did I do? Oh no, that worked. Oh, that is not 21. There we go. Okay, we're good now. Everything's great. Can we build? We build. Everything's fine. Set face size to here. Okay. That was a little diversion. So, okay, what we're going to do today is hopefully it's a short little stream because I got some stuff to do today, but I want to really get this done. Is we currently store array information in the tree in a really stupid way. So if you have a variable that's like u64, my array, and it's got 64 elements in it, if this is your variable, in the tree, this looks like a variable decal who's got a name, my array, and a type. So we'll say its name, and its type is u64, 64. That's it. So how do you know this thing is an array? I mean, it's also got a pointer depth of 1. You look at the pointer depth, and then you have to parse the string. It's really stupid, and it makes querying or manipulating array variables practically impossible, unnecessarily verbose, and it just sucks. So what I'm going to do today is upgrade the concept of an array to more of a first-class citizen on here, to have basically like array size and maybe array depth, because you could have like two of them, or like multidimensional arrays basically. So going forward, I would want something like this to look like basically my array is going to be full of U64s, array size. This is actually an array itself, and this would be 6432, and this would be 2 in this case. And then have like a helper function is array. It takes one of these nodes, and it just returns array depth, basically, right? So that's basically the agenda for today, is to get this to be a lot more robust, a lot more easily queryable, a lot easier to maintain, and a lot easier to manipulate. So let's get started doing that. The first thing I want to do is so I think this will be on the decal variable. I don't think it has to be on anything else. Pretty sure. So this can just be on the decal variable. And let's make a array depth, I guess, or array dimensions. And should this be dynamic? Yeah, this should be dynamic. So we'll say array sizes. This will be dynamic. Array of size, array dimensions. I think is what we want. So let's do that. Let's go to the parser and parse array params for decal. So here's where we do that. So let's set up a simple test case here. Let's just remove all this stuff for now. And we will just say my array 64. We'll just do that. And let's loop over it and print it out. Okay. Really? Primary chunk. How is this already failing? Line 2. Oh, it's because... Well, wait a minute. Why are we failing? It's not this. It is this. Oh, does it not know? Well, hold on. Parsing. Expected identifier after open got open. That error is also just wrong entirely. So parsing, parse variable decal after expected token identifier. So here, Is that really where it's failing? It must be. That's the only expect token that we have here. So next, well, let's just make sure that this is where this is happening. Yes. So next in this case is this square bracket, but it's not actually. So do we need to advance here? No. We're not advancing somewhere. There's somewhere that we're not skipping ahead. So let's see. We grab, it must be this, right? Yes. It's this that it doesn't like, which means right here. Why does it think this is a variable decal at all? That's the real question. Why does it think this is a variable decal in the first place? Because we should be in, you know what? Instead of guessing, let's just, I did not expect to bust out the debugger this early, but I gotta know what's going on. Let's go to parse variable decal. Actually, no, let's go to expect token. Let's go here. Okay. So the type we got was U64. The let's look at the variable. We got a U64. We don't have a name yet. Ooh, parse this is not a function decal. Why are we in here at all? So we say false if it's a parent open, which it is, until we say semicolon or equals, or an open curly brace. If we see either of those, it's definitely a function decal. No, if we see a semicolon, it's not. If we see an open curly, it is. And in this case, we eventually see a semicolon and nothing else. So why do we think this is a function decal? We get into here. Wait. Is this even... You know what? Let's break here and say that next line is 65, not 64. Next is S8. That's not true. Wait, we already break without ever hitting that. I'm confused. Where are we? Function or variable decal? So this is when we see void print. Where are we seeing void print here? There is no void here. Line 2. What file are we in? Primary. Oh, wait a minute. Oh, I think I know what's happening here. We are trying to generate a function that takes a array parameter. That's what's happening. We can't pass. It doesn't understand what this is. Again, because of the work that I have to do right now. So if I make this a U64 value equals this, and I print out the value, now we're fine. Okay, that was not the error I thought this was. So this needs to understand that my array variables on the tree are just a disaster right now, which is what I'm fixing. So I can't pass this in directly. It doesn't know how to deal with that. So that's fine. Let's go back to what we were doing. So here's my example. And if I look at the tree right now, so here's what needs fixed. Here's that variable, my array. Its type is U64 array of 64. That ain't good. That's just not how this should be going. So let's go to the parser again and say, well, let's set up a breakpoint on parse variable decal. Is that what this is? No. Okay, let's set up a breakpoint here, but let's do it on line 61. Okay. Next, no. Type line equals 61. Does that work? Type is S64. That's not it. Not it. Not it. Linux main. Okay. So also when the parser token cursor is 98. Now are we in the right place? Yes. Okay, so let's just see what's happening here. Pointer depth and reference depth are both 0. It's not an any type. Boom, 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 boom. Flags. Should I put a flag on it that it's an array? I don't think I have to, so let's not do that. Let's just not do that. It's none of these. So the next thing I see is the name. Okay, it's not an any of. It's not an ellipse. There's no open parentheses. We expect an identifier, which we should hit, which we do. The name is that. Skip it. Here we go. Yes. So, while the next type is this open square, okay, here's where we do this. So, parse array params for decal. This needs to, instead of what it's doing now, which is parse array params. Yeah, it's just appending on to the name with our stuff. That's no good. That is no good. I do need to know though. I need to know how big to make that array. So I need to know how big to make this, which means I need to know this up front, which we can just count the number of open square brackets, which I think count for character. So array dimensions is count for character. Oh, no. I'm not counting characters. I am peeking ahead for these. Until I hit a equals or a semicolon. I think. Equals or semicolon, I can stop. So array dimensions 0. Now, while we'll say peak index, while peak token index, peak index, type it's not equal. So as long as it's not an equals, if it's not an equals and it's not a semicolon, and you know what, let's do this. Peak this, if peaked type. So as long as it's not an equals or not a semicolon, we're gonna keep looping. We're gonna say peaked equals peak token index plus peak index. So we're just looping over token by token. And if we see an open square brace, we increase the array dimensions. There we go. Easy. Cool. So we now need to allocate this and set up our, so we're gonna say, is it parent? Parent. You know what? Let's call this decal because that's what this is. Decal array dimensions is array dimensions, and decal array sizes push array on the parser's arena array dimensions. Okay. So we count how many array dimensions this has. We assign that many to the decal. We create an array for those sizes. And now we need to set them inside. So, and you know what? Parse array params. We are going to say this function is going to just take care of the whole thing. So Okay. So don't need this. Okay, so we peek the next token. Um, while I guess same thing, right? It's not an equals. And well, yeah. We'll see if this needs to be more robust later, but I feel like this might cause problems, but we'll see. Okay, so while it's something other than those. No, you know what? We're gonna say we already know the next thing is a square brace. So let's just assume that this loop is going to keep going as long as we still see a square brace. That's how this should happen. So, and in fact, this isn't going to skip it. Let's just peek. Peek at the next one. Assert that it's a square bracket. Count, set, and now, while the next thing is an open square, we are going to skip it. Grab the next one. And okay, here's the problem. The size can't be a U32. These can't be U32s here. Because it might not be a number. It might be a variable that holds the number. Right? So these are actually nodes on the tree. And no, this is not, this comment was never even accurate. So, that's fine. Array dimensions, array sizes. Decal array sizes. Array index 0, array index plus plus is, we're going to parse expression. Parser. If I think this is okay. We just parse an expression there. And then I think that will stop us. Where is that going to stop us, though? Parse expression. Ideally, this will stop us at the closing square brace. I don't know if that's true, though. Let's just assume it is. So we will assert that we'll say next is peak token parser, and just assert, well, Let's just assert that next type is a token square close. And so I still need to grab the type. No, I don't. Never mind. This is all going away. Okay. So we just need to know that right here we are we need to know that right here we're getting a close a square brace. Oh boy. Push array. Oh, I didn't give we vibing. Although we're not vibing. Type is a metagen part. It doesn't actually know what this is, so I have to tell it that these are nodes. Peak index. I gotta pass the parser to it. Yep. I still did not pass it up here. This is a pointer. Array dimensions. Right. So this is on the decal node. So this is an info decal variable dot. So is this, and so is this. Okay. Operator equals parse expression node array sizes. Oh, this is these are not the nodes themselves. These are pointers to the nodes. Which means this is a pointer. Is it? Uh-oh. Uh-oh. I did turn something on that is new. Thank you for that. Boosh. Boosh. Okay. Now it shouldn't. Thank you. Okay. These are pointers to nodes. And parse expression will create and return that node. So that's right. Yes. Unrecognized symbol after data. Okay, so now we are in the thick of it because now it doesn't understand any of our arrays. So this is immediately failing. Unrecognized symbol after data. So here. Parse variable decal. So unrecognized symbol. Let's see. I need to go to where is it? Here. Okay. So we saw data. We're seeing the closing square brace, which is good because we didn't actually skip it then. I said this will be past the final one, but it's not. So let's tell it to go past it. So we assert that it is. So we are passing that. So now we just need to skip past it. Advanced token parser. Next equals peak token parser. There we go. So now we're skipping past it. Hey, we're actually still parsing these, surprisingly. That is actually impressive. So on 14 of main. So now it doesn't understand this, which is understandable. Let's do param decals. Let's just start here and say the line is 14. And we are in, nope, main. So the token cursor is 13. Okay. Okay, we're in main. So this first one should be no problem. We got a variable decal that is a type of int called numargs. Great. Next one is comma. Okay. Parse variable decal. Let's see what we get here. So flags are nothing. Type is char. Pointers and refs are a star because it's a char star. Okay. Pointer depth, reference depth, yep. It's none of these. Boom, 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 boom. Expect an identifier, which we got. Our identifier is the name, args. So we set it, skip it. Next is our open square. We found it. Let's go into it. Our next is an open square. Let's count how many dimensions of the array we have. We should have 1. So we see an open square. Boom. Go to the next one. Oh. This loop is going to actually fail because let's actually have this look the same. Let's have this loop look the same as this bottom one. So assert that the next one is a open square. We are going to as long as peaked is an open square. So while it's an open square, we increase this and we want to go until we hit the closing square. But we need the matching closing square. So for example, like you could have well, okay, not in this case, but if you had a variable, right? So if you had like this, and then you have sizes 3, right? When I'm counting these, I want the matching one for this. So I just ignore this one. This one doesn't count at all. The matching one for this is here. So the way you do that is, so as long as we see an open square, we'll increase the array dimensions. And then we'll say, square count is 1 because we're on the current one, and while square count, we will skip ahead. While square count, we look at the next one. If peaked type is a open square, we increase the square count, If it's a close, we decrement the square count, and the moment we hit 0, we're good. We've skipped past all of the ones in between. So that will put us, we're looking at the next one. It's a square. Okay. And then we go beyond it. Okay, that should be fine. So let's look now where we're at. Skip the comma. Okay. Let's go beyond the name. So this is args. Okay. Square open. Let's look at this. Okay, we see an open square. We know we increase our array dimensions by 1. The next one is a closing square. So we're 0 now. Peaked is now the parent close. So we're done doing that. We set our array dimensions, we allocate the array. Next is, we're still, our original cursor is still at the opening part. Next is the square close. Oh. We might not have a size. We might not have a size. So before we do this, if next type is a token square close, then this one is 0. So let's actually make a note of that for later. Size of 0 signifies a parameter. For example, okay. So not everyone will have a size in it, which is fine. And when we do that, we just continue on to the next one. But we need to skip past it and grab the next token when we do that. So look, we're parsing again. We have a whole bunch of problems, but we're parsing again. So if we look at the tree now, if we look at the tree, where are we? My array, its type is now just U64, but it should have on it that array information. So if we go to where we print out a node, where do we do that? Here, a decal variable. So the name. So when we do the name, we still want it to look like it did before. So we're gonna say we want this to say name, boom. We still want this to say U64, whatever I'm saying. We want this to look like this on the tree, like that. So, but instead of this being baked into the type string now, we're getting it more robustly via data on the node. So that is here. So after we print out all of this stuff, we can say if info, you know what, we're using this whole time. We know this is a variable decal, so what did we call this? Decal info variable. Let's just do this. So instead of node info decal variable dot, node info decal variable dot, it'll just be info. Okay, so we'll say info array dimensions. Actually, this can just be a loop. So for dim ID, so for each dimension of our array, we're going to print out a open and a close, and in between, we're going to say if info array sizes dim ID. So only if there's a number to actually print there. We will int to string. No. Because that could be. That might not be just a number. Right? That could be a whole expression. So man, see, that's why I feel like this needs to be a child of the thing. You know what? I guess you don't need to see that in the tree. What does this do? Does this print out? Literals? I guess it does. We'll just say print node nicely here. Print node nicely. This is probably going to be gross as hell, but I think it'll get the job done. We just won't be verbose about it. Okay. So, my array. There we go. So it's a U64, size 64. That's exactly what I wanted. And now we can query this without having to deal with any dumb string stuff. But the problem is our code gen doesn't yet know how to do that. So I need an example of this. So I guess we are spitting it out, right? So let's see what the first error is. Second argument of main. Okay, so literally the very first argument to main, you can see an example of what's happening now. So I feel like this file should move to the gen directory, actually. Let me make a to-do for that. Move db meta generated to the gen directory. Give it a new name. Okay, so if we look for main here, so you can see this used to print out that, right? Now that I've moved the array information to be part of the node and it's not in the string for the actual type, the code gen has no idea that it has to write out an array, right? So do I do, how do I do this? Node as string. So here we go, decal variable. Yeah, so here's currently what I have to do to print out these arrays. It's really stupid. I'm literally doing string parsing for these, and it's just stupid. There's no reason to be doing that. Embedding the array information in the strings, I should have never done that from the very start. It was a bad idea, and I did it because I was lazy, so it's really good that this is getting taken care of now. So, if we're gonna say, do we have a node info? We do that here too. Info is node info. Node info with just info. Nope. Node info dot with info arrow. So if no info array dimensions. So if this is an array, right? No, hold on. So forget this. What are we doing here? Omit type. Oh, right. This is because we're okay. Yeah, we don't have to do any of this stupid stuff anymore. This was a lot of duplicate code here that was just dumb. So we can print out the type in its entirety, references, pointers, print out the name in its entirety, and then if we have array dimensions to print, let's just do it. And in fact, again, this can just be a for loop. Okay. We will just do if info array sizes dim ID. So if we have a node for our size, we will append that node as a string in between the brackets. Now, I'm not going to get too ahead of myself, but I kind of feel like that's all that needs to happen here for this to just kind of work. Append node as string, it takes the builder, the file path, write lines, and synthetic line numbers. Let's take all that stuff, I guess. Okay, cannot convert node, oh, yep, that's right. So this is not an info, this is a decal variable. Info decal variable dot with info. Okay. That's fine. All right, let's stop printing out the tree for a second. Let's see what's going on now. Still a lot of errors. But we are no longer failing on main, so I think that's good. Let's take a look at what we're spitting out here. So there we go. We're printing this out again properly. So that's good. And my array. Okay, we don't want line numbers here. I admit that's a mistake. So when we go to print out the here, right line, we don't want to print lines. No problem. Bro, there is no way this is going to be that easy. There's no way. Secondary chunk 83. String on type info. Oh, that's an array, isn't it? Type info. That is here. All right, it's trying to print out member names. The address will never be... Oh, right, duh. So now the metaprogram that's generating those functions does not know, also does not know about the way arrays are represented now. Yep, so here's my to-do, right? Trying to do this raw dog on the string is just not worth it. Not to mention we lose all the context of like what the size is. Right, so this is exactly what I didn't want to do. I have to remember what we're doing in here though. So a struct member, what is this in? Generate struct templates. Wait, this is actually not... This is where we left off last time. This is actually not what this problem is. This is in toString generation. Two strings. This is in here. Yeah, how do we handle arrays? So instead of this check, we're gonna say, we're just gonna skip over arrays for now still. We're gonna say if member info array dimension. So if it's an array, skip over it. And we are running already. I was not expecting that to be this easy to get us back up and running already. So I admit that's a little surprising. Let's try this real quick. Let's just say that. I mean, there you go. We are back to working, and we are successfully parsing arrays. And I think this can be a variable, and it'll still just work. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think. Oops. Dude. That is fantastic. This may be a short stream. I was expecting this to take a lot longer. And it's totally not the case. There we go. I mean, we did it, right? The size is in this case, the size we're passing is an expression. It's not just a number. And it still just worked. So, yeah, that is surprising. But I'm not going to complain. Let's try multi-dimensional ones. So let's create like short string multi. It'll be like 10 by 10. Or no, let's do 10 by size. multi to 4 hello world, and how about 4 will be goodbye world, and we'll say print 1 2 Dude, I cannot believe this is just working. I mean, there you go. We're cooking. Multi equals, I mean, there you go. 10 in size. Dude. That was so easy. I feel like something should be horribly broken, but it's not. There's actually a lot going on here in the background with like the metaprograms and stuff that this would be breaking otherwise. Yeah, like we're still working in all these other, like, this is just working. So, huh. How long have I been streaming for? This took an hour. That's all right. So let's see. That means, so does that mean here when we generate 2 string functions, I still don't think I can do anything there, but when we are printing struct members that are arrays, so here's what the problem is right now that I was trying to fix before. So this to do I think can go away because that's what we just fixed. So any struct 2, you can pass in a size, and we will create a version of the struct that has arrays of that size. So for example, I can create one of these and say it's full of F6, it's full of floats, and the array sizes inside are all 32. So like here is 32 in this case. So dynamic will have a size of 32. Fixed we'll say is 16, and capital size is, do I have a size? No. We'll say it's 1024. So this should work. When I say any struct 2, floats 32, it should create one of these that has a dynamic array of floats. Well, it's still static, but it'll create one called dynamic with a size of 32. This will be 16. This should be 1024. And if I compile this right now, I don't think this works. Right, because it doesn't know when I'm spitting it out in the metaprogram, it doesn't know how to handle the arrays. That's what this was doing here. So we can remove all this. If this is an array member, it could have a size. So we're not even going to do, see, this whole stupid query thing is just not, we don't have to do any of it anymore. So the child info, if the child has array dimensions, then okay, actually this is going to be more complicated because now we're actually spitting out the this I'll have to come back to. So see if any of our sizes for array members are coming from parameters to the template. So replace them. Okay. That's more work than I want to do tonight. That was shockingly simple, and now we have really awesome, robust arrays in the tree. To do, still getting this to work next. C to do in metagen metaprogram line 552. Okay. Let's leave this in a compiling state. Actually, let's not. Next time I come back, I will see that this is where I left off. So then after I do this, the next thing to support is any of on these. So right now the size, like the type here, in this case I'm saying so like in this case I'm saying, okay, if you pass me a size for this array, whatever type you gave me here, I want to use it as the type for the counter as well, and I want that to only accept unsigned integers, so it needs to support any of inside of here. So that's the next. Once this base version works, that'll be where I go next. Still have more to do, obviously, but man, I kind of took a break from working on this, and I was a little worried. Like, it's been at least a week or two. I was kind of worried I'd come back and not know what I was doing, but this is a great way to start that back up. So let's more robust array information in the tree. Array information is now stored on the node itself and not embedded into the type string. Okay. Great. Well, okay. Well, thanks for watching. This was a much shorter stream for me, but hey, I count that as a success. Did some good stuff today in this short amount of time. So, all right, cool. I'll see you guys next time. Thanks for watching.